Welcome back. Let's expand a little bit on this idea of substances. So substances can be categorized as either elements or compounds. Okay, an element is the simplest substance we can work with. And for a while in chemistry was the smallest one that could not be broken down anymore. Then, of course, nuclear chemistry came around and that idea kind of changed. But let's assume for now it cannot be broken down by chemical means any further. A compound is two or more elements that have been combined in a fixed ratio. Now, one idea that's kind of confusing for students is a compound has completely different properties from the elements that make it up. So if you think of hydrogen, it's a very flammable gas. If you think of oxygen, it's another gas. But if you think of water, which is H2O, it's a liquid and it's used to put out fires. It's water, right? So they're very different properties. And the reason for this, we're going to delve into a lot this year, has to do with how the particles are arranged and what's happened with the electrons to cause them to interact in a certain way that you end up with a substance with different properties. You're going to want to find your reference tables. These are in your binder in the course information section. And there's a whole bunch of common elements we use. Now the names for the most part are on this table, so you can fill them in. So take a minute to pause and fill in all these names. And it's going to be worth knowing these because these are things we encounter over and over again. So I'm not going to put the answers up here, but again, you can use those tables to fill in. The only ones I do want to talk about are the compounds, okay? And the compounds here are the last two. That's why they have the stars. So carbon dioxide is going to be CO2, the 2, okay? And water is going to be H2O, and those are both subscripts. Those numbers are just a little further down there. What we want to talk about with matter is something called a particle diagram. So we've already kind of delved into this idea that matter is made of particles. Okay, for an element, we can have what we call one particle, a monatomic element, the prefix mono meaning one. These are most elements. Okay, however, there's some elements like oxygen and hydrogen. They exist in nature as O2 or H2, and we'll talk more about that idea later. But these would also be considered elements as well. So an element is either a single circle, okay? This one and this one would be two different elements because they're two different colors, or two of the same colored circle together. Compared to a compound, which is going to be two or more different circles together. So this would be one type of compound. This would be another compound that could form with those same elements in a different ratio. And this would be a third compound that's composed of three different elements. When we look at a particle diagram, we want to be able to say if it's an element or a compound. So pause and try these three. Tell me, is it showing an element or a compound? How'd you do? This one's an element. All of those circles are the same. This one over here is a compound. Each individual particle here, so I'll consider this one particle or one formula of the compound, has two different elements touching, chemically combined. This one's a little trickier. It is two circles, but since they're the same, this is considered an element. Remember, me talking about oxygen and hydrogen in the previous video, or the previous slide, excuse me. How about if we want to draw a mixture? This gets a little bit more complex. But what we could do is we're going to show kind of two of these together, right? So I could pick perhaps this element and draw a bunch of those particles. And then I'll make a new compound composed of this element and this element. And I'll draw a few of those. Okay, and again, those should be touching. And I'm just going to kind of scatter them about. We'll talk about how they're arranged in a little bit. What is a mixture? A mixture is two or more substances, so two or more elements or compounds that are combined together, but they are not chemically combined. They're only physically combined. So they keep the properties of their individual substances. right? So we can classify mixtures in two ways. The first way, we just want to look at a particle diagram, and we want to say, is it an element in a compound? Is it two or more elements, or is it two or more compounds? Try these. How'd you do? This one here is two elements, right? There's the black circle element and then the white circle element. This one's also two elements. This time we have a diatomic element, but these are also considered elements. This one down here is showing two compounds, right? Each of the two different compounds has two or more different colored circles touching each other. This one over here is arranged a little differently than this one. We'll talk about that in a minute. But this is showing a compound here, and this is showing an element. So this would be a mixture composed of an element and a compound. We can also classify mixtures as being homogeneous or homogeneous, or heterogeneous, right? A mixture where everything's evenly distributed is also called a solution, or a homogeneous mixture. And this is something like if you think of Kool-Aid or lemonade or gas or pulp-free orange juice. These substances, the top of these mixtures, the sample at the top of the Kool-Aid is the same at the bottom of the Kool-Aid, or there's no layers. One way to really kind of think about heterogeneous mixtures that helps is think, does it have layers? A heterogeneous mixture is not evenly distributed. It often will have layers. Like if you think of a Greek salad dressing, before you shake it, has the different layers. If you think of an ice cap that's been sitting for a little while, it has different layers, the ice and the liquid. Blood's a little tricky because blood kind of looks homogeneous, but if you zoom in just a little bit with the microscope, you can often see different components of the blood. And pulpy orange juice would be an example of a heterogeneous mixture because it has the top layer before you shake it and the pulp at the bottom. You can temporarily homogenize a heterogeneous mixture by shaking it, but it does go back to having those different layers. We can also look at these in terms of particle diagrams. Try and label each of these homogeneous or heterogeneous. How'd you do? This one here would be a homogeneous mixture. The particles are scattered around. This one over here would also be homogeneous. The particles are also scattered around. This one down here is going to be heterogeneous, right? Because you kind of have a clear layer here. On the top, you have this first compound, and on the bottom, you have this other one. This might be like sand and water. This one over here is homogeneous. Even though these particles are lined up, kind of implying they're a solid or a liquid, they're evenly scattered around. So we call this one down here also homogeneous. For it to be heterogeneous, all the same type of particle would kind of have to be clumped together. This chart summarizes the different classifications of matter, and we're going to refer to this over and over again. This helps show that matter can be characterized into substances and mixtures that can be changed through physical changes, right, which we'll talk about in the next video. Mixtures can be categorized as heterogeneous or homogeneous, and substances can be categorized as elements or compounds. When we talk about a chemical change, we're talking about switching from a compound to two or more elements, or from two or more elements into a compound. In the next video, we'll expand on this idea a little more.